For our last section of notes for Unit 3, we're going to continue looking at our triangle congruencies, the 5 shortcuts that we went over yesterday, but we're going to be looking at more complicated examples. So when you're proving triangles are congruent, there might be some concepts that we discussed in Unit 2 that would apply. So for instance, vertical angles. Anytime you have an hourglass or kind of bow tie look, you have a pair of vertical angles. And if you remember correctly, vertical angles are congruent. So those two angles, make sure you use the angles in the triangles because we're looking at the triangles, those would be congruent. Here, I cannot say angle F is congruent to angle F because there are a bunch of different angles coming off from point F. So you would have to be more specific, like angle EFD. Make sure you put F in the middle because it's the vertex, is congruent to angle, and then pay attention to the order GFH. So unlike yesterday, your triangles were separated, and so you had to be given all of the information. Today, you are going to need to, I don't want to say assume because you're not assuming, but you're going to have to use some reasoning and some previous vocabulary to conclude that certain angles or potentially sides are congruent even though they're not marked. So again, if you have that hourglass or bow tie look, you definitely have a pair of vertical angles that you can mark congruent. If you have parallel lines, the most common type of angles that you're going to see are alternate interior angles. So in this, okay, you see that bow tie look again, but don't assume if it's a bow tie that they're parallel. You're going to need to either be told they're parallel or you're going to need to have the little arrows to indicate that they're parallel. But angle B and angle E are congruent because they are alternate interior angles. Likewise, angle D and angle A are congruent because they are alternate interior angles. So just by knowing those lines are parallel, there are two pair of angles that you can mark congruent. And in this particular picture, you also have a vertical angle. So you could mark angle BCA and angle ECD congruent as well. So you actually know that all three pair of corresponding angles are congruent. So you'll be able to add some marks to your picture. This type of picture doesn't happen very often, but you could potentially have corresponding angles. You don't have the bow tie look in this one. You have kind of two triangles that look like they've been translated essentially. Because AB and DE are parallel, then that makes A and D congruent because of corresponding angles. And because BC and EF are congruent, then angle EFD is got to be congruent to angle BCA. I could call angle EFD angle F because that's a singular angle, but I couldn't call BCA C because there are two different angles coming from point C. There's BCA and then there's BCD as well, so we'd have to be careful. Again, we don't see corresponding angles as much as alternate interior angles, but it does happen from time to time. The last piece of information is something you haven't learned yet, but it's called the reflexive property. The reflexive property happens when, and it can happen with angles, but we won't really see that until the next unit. It's when a side or an angle is shared in both pictures. So in this picture, RT is a part of both triangles. So that means RT has to be congruent to itself. which should kind of make sense. I mean, something's definitely congruent to itself, but you would want to mark it in the picture because now that's giving you another side that you can use as one of your pieces for your triangle congruency, one of your corresponding sides. Sometimes on these pictures, you might want to redraw them so that they're separate, so that you can see those corresponding pieces better, but that's really just a preference. So we're just going to go through some pictures, and we're going to start by deciding what piece is congruent to what I give you, whether it's a side or an angle, just based on the congruent statement. So for A, we're looking for what is congruent to segment LM. So first of all, don't write an angle. If I give you an angle can only be congruent to an angle. If I give you a segment can only be congruent to a segment. Don't tell me an angle, which is measured in degrees, is equal to a segment, which is measured in units. That does not make sense. So what you're going to want to do is you're going to want to use that congruence statement. So I'm focused on LM because that's what it's saying. LM is congruent to what? So look in your triangle congruence. Here's L and here's M. What two letters are in the same position on the other congruent statement? Well, L was in the middle, but K is in the middle. M was in the third position and R is in the third position. So that means that LM is congruent to KR. If you're visual, you might be able to see it visually as well, but I think that it's easiest just to look at that congruence statement. But if you look at LM in the picture, LM is right here, and that is going to go with KR. If you kind of rotated LMK around, it would lie on top of, LM would lie on top of KR. All right, for B, we're looking for what angle is congruent to angle S. So we know it has to be another angle, so I'm going to go ahead and write the angle symbol. Use the congruent statement. Angle S is in the third spot. So angle I is in the third spot as well. So angle S is going to be congruent to angle I. I'm going to rewrite that just because it doesn't look very neat. Now, in both of these, even though this isn't in there, I'm just going to kind of go over it because it's newer. On A, there is this reflexive side. It is shared by both triangles. So you know that LK has to be congruent to itself. In B, we have that bow tie look, so we know we have a pair of vertical angles, so we could add that in there. Not that we needed to, but just kind of re-emphasizing those concepts. Okay, now we're looking at some triangles and we are deciding why they are congruent if they're congruent. So we're either going to say whether they're congruent or not. If they are congruent, we're going to specify whether it's side, 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 angle, angle, side, angle, 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 side, or hypotenuse leg. And if it's not, if it is, we're also going to give the congruent statement. If it's not, we're going to say no, and we can discuss why. All right, so in number 1, don't let looks be deceiving. Don't assume that those are two right triangles, okay? Because an assumption is never a good thing. Don't ever assume. We do not have a right angle, so don't mark it. What we do have is we have this side, ST, which is a part of both triangles. So that is a reflexive side, so you can mark that congruent, and that would be a third side. You already have AS and IS are congruent. You also have IT and AT are congruent. So by adding that third reflexive side, you now have that all three sides are congruent, which makes the two triangles congruent by side, side, side. To do our triangle congruent statement, I am going to do triangle SAT for the triangle on the left. The triangle on the right, pay attention to the corresponding pieces. S is between purple and red, so if I look between purple and red, that is also S on the triangle on the right. And then A is between purple and blue, so that's I. And then T is between blue and red, so that is also T. Two of the letters in both triangles are the same because of that reflexive side. On number 2, all right, let's go through what we have. We have OB and IB that are congruent. That's one side. We have WB and GB that are marked congruent. That's a second side. Two sides is not enough. We don't have side, side. We do have two potential that have two, at least two sides in it, side, side, side. So in order to use side, 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 I would have to know that OW and IG are congruent, and there is no reason for me to know that, so without assuming, and again, we don't want to assume. What we do have, because we kind of have that hourglass or bow tie look, we do have a pair of vertical angles. So angle OBW and IBG are congruent. So by adding that pair of vertical angles, I now have two sides, and I have the angle that touches both of those sides. That's called the included angle. So these two triangles are going to be congruent by side angle side. For my top triangle, I'm going to call it BOW. And for my triangle on the bottom, B is going to correspond with B in the bottom triangle. And then to get to O, I've got to go past the green. So I'm going to do the same thing, start at B and go past the green, which is going to take me to I. And then I'm going to go across the side that isn't marked, which is G. Pay attention to that order. It is very, very important. On number 3, we have AC and EC that's marked congruent. That's one pair of sides. We have no other sides marked congruent. All right. We also have angle B and angle D marked congruent. So we have a pair of sides and a pair of angles. That's not enough. We do have that bow tie. So that means that this vertical angle right here, ACB and ECD, are also going to be congruent. So we have two angles and a side. So our options would be either angle, side, angle, if the side that they're given us touches both angles. It does not. Or angle, angle, side, if you have two angles and the side touches the same corresponding angle, which is what it does because AC and EC both touch the green vertical angles. So that means these two triangles are congruent by angle, angle, side. I'm going to call the first triangle ABC. And on the right, A does not have a congruent mark, and neither does E. So I'm going to start with E. B has one congruent mark, so does D, and then that leaves me back to C, which is congruent to the other C because of vertical angles. Let's try some more examples. So for number 4, we have segment BT and segment RT are marked congruent, so that's one segment. We have angle BAT and angle RAT are marked congruent, so one angle. One side and one angle is not enough. Is there anything that we can mark congruent? So you want to look for vertical angles. We don't have any vertical angles. You want to look for a reflexive side. We do have a reflexive side. We've got AT, which is part of both triangles. So we do have two sides and one angle. The only congruent statement that potentially works with two sides and one angle is side angle side. In order to be side angle side, the angle must touch both given sides. It must be in between or be the included angle. The angle that we have only touches side AT. It does not touch side BT or RT. So these two triangles are not going to be congruent. For number 5, we have two sides marked congruent. We have LI and we have TH. We also have IG and HG. Two sides is not enough, so we have to look and see, is there any other information that we know? This does have that bow tie look, so we do have a pair of vertical angles. So we do have two sides and one angle. The only congruence that works with two sides and one angle is potentially side angle side if the angle that we have touches both sides. It's got to be included or in between the two sides. So the angle that we have only touches IG and HG. It does not touch LI or HT, so it is not the included angle, so these are not congruent. On number 6, we have one given side, BU and MO. We also have a right angle. One angle and one side is not enough, so we're going to look and see if there's anything else. There is the shared side, MB is in both triangles, so you can mark that. That is the reflexive side. Now this is a right triangle, which means it could potentially be hypotenuse leg if you are given a hypotenuse and a leg. The hypotenuse is opposite the right angle. It does not touch the right angle. So in this picture, OB and UM would be the hypotenuse, and they are not marked congruent. So this is not hypotenuse leg. That doesn't mean they're not congruent. They could be, but it just might not be by hypotenuse leg. It could be by another reason. So we do have one for two sides and an angle. We kind of talked about it with number 4 and number 5. And that's side angle side. But again, the angle must be the included angle. It must touch both sides that are given. And so angle, the right angles do touch both sides. So this is side angle side. So I'm going to call the first one triangle, let's just go MOB. And then the second triangle, M in the triangle on the left is the right angle, so that matches with B in the triangle on the right. O, you go across the purple side, so go from B across the purple side, that's U. And then across the hypotenuse would leave you to M. Okay, so just a few more examples. Now on 7, this is a little bit different because we don't have anything marked congruent, but we do have measures. This might be one that is helpful to draw the triangles separate. That's up to you. You definitely don't. So we have AS, which is 9. We have AE, which is 6. And then we have ES. We have it in two pieces, ST and TE, but if you add 5 and 6 together, that gives you 11. And then for the other triangle, we have TW is 9, and then T to E is 6, and then E to W is 11. So what they've given us here are all sides. We have no angles marked congruent. There's no angles we can conclude are congruent at this point. But if we focus on the sides, all three sides have the same length. So these are going to be congruent by side, side, side. You can see AS and TW both 9. WE and SE both 11. And then finally, AE and TE are both 6. So if it helps draw it out, do that. But if it doesn't, then you certainly don't have to. It's whatever you want to do. Let's get our congruent statement. Triangle, we'll call it SEA. S is between purple and blue, or between the 9 and 11, which is W on the other triangle. E is between blue and green, or the 11 and 6, which is E on the other triangle. And then A is between the 9 and the 6, or the purple and the green, which is T on the other triangle. All right, on 8, we have one marked side, HT and ST. We have a right angle, so angle H and angle S. As of right now, that's not enough, so we got to think about, is there anything we can add to the picture? WT is part of both triangles, so that is a reflexive side. So one of the things that I noticed right off the bat is that there's a right angle, and if there's a right angle, it might be hypotenuse leg. We did an example a minute ago where it ended up being side angle side, but let's go ahead and check. In order to be hypotenuse leg, you have to have the side opposite the right angle marked. So the side that does not touch the right angle, and that would be WT, that is the hypotenuse for both of those triangles, and then you need to have one of the two legs. The legs touch the right angle, and so that would be HT and ST. So these two triangles are congruent by hypotenuse leg. So the triangle at the bottom, we'll call that STW. S is my right angle, so in the triangle up top, that's going to be H. Then we're going to go from S to T, we go across the red, so that would be H to T, and then finally T to W. All right, and number 9, we have PN and CL marked congruent. We also have that PE and CR are parallel. That means we have a pair of corresponding angles. Angle P and angle LCI are going to be congruent because they're corresponding angles. We also know that NE and LI are parallel. So that means angle P and E and angle L are congruent because they're corresponding angles. So if we look at what we have two angles marked congruent, and we have the side that touches both of those angles marked congruent. So these two triangles are going to be congruent by angle, side, angle. For the triangle on the left, I'm going to call that PEN. And then I'm going to look at the triangle on the right. I'm going to match them up. P and C are marked congruent, so they correspond. E and I have no congruent marks. Those are going to correspond. And then N and L are going to correspond. All right, we got 3 more examples. On 10, we have YA and YO marked congruent. That's a side. We have a right angle in both triangles. So one side and one right angle is not enough. We're going to look for any of those things that we can mark congruent. And we have YD is that reflexive side. It's in both triangles. So because it's a right triangle, I'm going to check for hypotenuse leg. And in order for it to be hypotenuse leg, it has to be a right triangle, which it is. We have to have the hypotenuse marked. The hypotenuse is opposite the right angle. It does not touch the right angle. So that was the legs, or the sides that we were given, the OY and the AY. Those are the hypotenuse. They are marked congruent. And then we have to have another side, which would end up being the leg, and that's YD, that reflexive side. So these two triangles are congruent by hypotenuse leg. Triangle YOD is going to be congruent. Make sure you pay attention to the order. That would be Y, then A, then D. 11, the only thing marked congruent is this right angle. There is nothing else marked congruent, but you do have that GH and FJ are parallel, and FH is a transversal. So that is going to mean that GHF, this angle right here, is going to be congruent to JFH because they are alternate interior angles. You cannot mark the other two angles, GFH and JHF, congruent because you don't know if GF and HJ are parallel. But you also have HF, which is in both triangles, so that is a reflexive side. So you do have two angles and one side. Even though this is a right triangle, we can check for hypotenuse leg. The hypotenuse is marked, that's that reflexive side, HF, but we don't have another leg marked congruent, so this is not hypotenuse leg. Don't confuse the parallel mark with a congruent mark. Can't use hypotenuse leg. If we have two angles and a side, our options are either angle, side, angle, 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 side, or potentially not congruent if the pieces don't correspond. So in order to be angle, side, angle, the side that we know must touch both of the angles, and it does not. It only touches those alternate interior angles. It doesn't touch the right angle, so it is not angle, side, angle. For it to be angle, angle, side, it will only touch one angle, and those angles should be corresponding, which is what we've got going here. It touches both the alternate interior angles. So that means these are congruent by angle, angle, side. I'm going to call the triangle kind of to the left, FGH, and then the triangle on the right is going to end up being, this one's a little bit tricky, H, then the right angle, J, and then HJF. Be really careful when you're naming that. Colors may definitely be helpful for that one. All right, finally, we have two angles. We have angle A and angle S. We have angle B and angle, well, we can't call it B, but SBT and ABC. And then we have a side AB and BS. So we have two angles and a side, and we have two congruencies that could potentially work. There's angle, side, angle, or angle, angle, side. In order for it to be angle, side, angle, the side that they gave us has to touch or be included between both angles. And side AB touches both angles. Side SB touches both angles, so this is angle, side, angle. All right, so we know it's angle, side, angle. We just got to get our congruent statement. I'm going to call the triangle on the top ABC. I'm just going to pay attention to my congruent marks. A has one mark, S has one mark, B has two marks, B has two marks, and then C has no marks, and T has no marks. Okay, so remember that you have 5 triangle congruencies, side, side, side. That means all 3 sides are congruent. Don't assume. You have to know that by some, it's either given to you or maybe you've got a reflexive side that you can mark. Angle, side, angle, 2 angles, and the side that's included, that means the side that touches both angles. Side, angle, side, 2 sides in the included angle, the angle touches both sides. Angle, angle, side, 2 angles, 1 side that touches one of the pairs of corresponding angles, and then hypotenuse leg must be a right triangle. You have to know, you have to be given the hypotenuse and one of the legs. Just because it's a right triangle does not mean it's hypotenuse leg. But in order for it to be hypotenuse leg, it has to be a right triangle.